Hi, Marco. Hello, everyone. Can you hear me?
Yeah, we can hear you.
Okay, perfect. Okay, let me check something. Hmm, I'm not sure if Michael Moy is going to join us, but let me ask him. Give me 1 second. Okay, so let's start this training. I talked to Michael Moy. He was the Bentley colleague that organized or arranged this training for your company. But he says that he won't be joining us, that we can start the training. So, um, well, first, let me introduce myself. My name is Eric Castillo. Uh, I'm going to be your instructor uh, for the following 3 days. I'm going to teach you the basics of the STAAD Pro program, and after this first 3 days, uh, you're going to learn how to model, analyze, and design steel structures. But in general terms, like you can apply it to any kind of a structure, buildings, uh, uh, I don't know, platforms or industrial structures. What we're going to learn here is just the basics. Um, after this far, after this first part of the training, you're gonna uh, you're going to have uh, a second part that will be more focused on uh, designing substations, and that's going to be another instructor. But for now, I'm going to take care of this first part. And okay, let me turn off my camera, and then I'm going to share my computer screen. And let's start with something with the basics, with the licensing uh, configuration. Can you see my screen? Can you see my?
Yeah.
Okay, perfect. Uh, right here on my desktop, I have the programs that you should have on your machines. When you run the STAAD Pro installer, automatically the installer installs these 5 applications: the connection client, another application with a blue icon called RCDC 20. Well, ignore the version. Let's just say that this is the RCDC program. You should also see a light blue icon called STAAD Foundation Advanced, another blue icon called iTwin Analytical Synchronizer, and the main application, STAAD Pro. It is a red icon, and it has the shape of a building. So before we continue, do you see these icons on your computer? Yeah. Okay. Okay, perfect. Um, so now let's talk about licensing. Once you have these programs installed, you need to uh, have a license to open these programs, and this license is registered, or it's detected using the connection client. Right now, the licenses are assigned to one email, and based on the email you use to log into the connection client, we can know if you have a license or if you don't have a license to open the programs. For example, let me show you. Oh, wait a minute. Let me try it again. I want to show you the connection client window. Okay, this is the connection client window. Here you will see some ads or information about our products in the connection client window. For example, here I can see that I have an update, a recommended update. There is no need to update the programs. I mean, this is just a recommendation. You decide if you want to continue with your current versions, or if you want to update something. But it's not mandatory. It's just a recommendation. Uh, what's important here is that you can see your email at the top right of the window. You should see some initials, top right of the connection client. And here, I think we provided an email for your company, so all of you can have a license. And in a few words, the email that you are seeing here, that email has a license, has an STAAD Pro license assigned to it. And that's why you can use the programs. Um, but well, this is mandatory. This is a prerequisite that you need to log in to the connection client, log in with a valid email, an email that has a license assigned to it, and then you can open the Bentley products that you that the email has permission to open. So, okay, in my case, I can see my email. My email has a license assigned to it, so that's okay. Um, I can close this application now. I can click on the X, and the application will is still running at the back end. I cannot see it, but the application is running. Uh, And every time you turn on your computers, the application starts automatically. You don't need to sign in every time you turn on your computer. The applications just runs automatically, and it uses the last email you used to log in. So let's talk about these other three blue icons. We are not going to see uh, what these applications do, but just for your information, uh, let's talk about them very briefly. For example, the iTwin Analytical Synchronizer. This program will allow you to uh, send your STAAD models to third party applications. For example, if you use Revit, you can send your STAAD model to the iTwin Analytical Synchronizer and then send it to Revit, or send it to Tekla, or maybe send it to another uh, program that is not exactly a Bentley, a program developed by as a link. Yeah, yeah, go ahead.
Yes, hi. This is Saeed. I just have a quick question. Can I do opposite? That means if I have a Revit model and I need to do the analysis, right? So
Yeah,
can I transfer from Revit to STAT Pro?
yes, yes. This workflow is bidirectional. It means that using this program, this blue icon, you can port a Revit model and then set it to a STAAD, or vice versa. Start your model in a STAAD, send it to the iTwin Analytical Synchronizer, and then send it to Revit. It works in both directions. Um, but again, this is only a brief description of the program. We are not going to use it. Maybe later, if you're interested in learning more about this application, uh, we can save some time to talk about the workflow. Uh, This other blue icon, the RCDC, the blue icon with an arrow, this is an extension of the STAAD Pro program, and we are going to use the RCDC to design concrete structures. It could be a column, it could be a beam, it could be yeah, basically those beams and columns. The advantage of using the RCDC application is that it can give us drawings. We can see a drawing of the column, how the steel reinforcement is placed inside the column, and more. But that's the objective of this application, the RCDC. It allows us to design concrete structures, beams, concrete beams, and concrete columns, and we can print drawings directly from this application. And the last one is the STAAD Foundation Advanced. With this application, like the name says, we are going to design foundations with this program. We can design isolated footings, combined footing, or mat foundation. And well, that's the objective of this application. And well, yeah, go ahead, Said.
Yeah. Can we design the pile cap?
Yes, pile caps is included also with the STAAD Foundation plans. And
it's part of this training session, right?
it's for the second part.
Okay, I got it.
You're going to see this application in the second part of the training. So now let's talk about the main application, the STAAD Pro program. I'm going to open it. I'm going to show you the initial window of this program. Double click on the red icon, and this may change according to your configuration, but probably some of you will see this window when you launch the STAAD Pro program. It is asking you to select a license before launching the program. This means that the STAAD Pro can be used with different types of licenses. For now, I'm just going to ignore this message and click on continue. And I know there is a message that says that that you may incur additional charges if you continue with the program launching. But don't worry about that. Ignore this. We provided you a license that is protected. You don't have to worry about charges, additional charges. So ignore this. You don't have to worry about possible charges. So let's ignore this and let's click on continue. Some of you may have not seen that message. Again, it depends on your configuration, but we're going to open it again from the initial window. So we all see the same thing on our machines. Second, this is the initial window of the STAAD Pro program. At the center, we will see the files that we worked recently. On the right of the screen, on the right side of the screen, we can see the license that you have active. For example, in my case, I can see that I have an STAAD Pro license and another additional license called Structural Select Entitlements. Maybe you have a different license configuration here, but don't worry. Again, we provided you a license that won't generate additional charge or any kind of charge. So don't worry about this, but it's important to know that STAAD Pro can be used with different types of licenses. So how can I configure the licenses? In the initial window, on the left side of the screen, on the red background, there is an option that says license. Let's click on that option. And a new window will appear that shows you the license configuration. Because we're going to learn the basics of the program, first part of the training, there is no need to activate the let's say the most advanced licenses. But we are just going to work with the basic license of this, the STAAD Pro license, the basic license. So type recommendation STAAD Pro, and for the additional licenses, uncheck everything except the structural select entitlements. How your license configuration appear on your machine. Here, another quick comment. When we select the STAAD Pro based license, we will have limited access. But again, this training is a basic training to access the most advanced features in the program. So the basic license for us. Maybe for the second part, if the instructor thinks is necessary, they will ask you to change your license configuration to the advanced option. But for now, let's keep things simple. Let's use the basic license and select the structural select entitlements license from the dialog box. Let's click on the accept button, and that's it. Now we can work with the program. Another thing that you need to know before creating a new model in STAAD Pro is the program configuration, like the units that we're going to use, the global axis of the program, and well, basically these two things. And to check those things on the left side of the screen, we are going to click on the configure option. Automatically, a new dialog box will appear. We can see some basic configuration of the program. Here, I'm going to recommend changing the base units to the unit commonly used. For example, for this training, I'm going to change it to English. But maybe if you need to work with someone in Canada or maybe in Europe, you may want to change the units to metric. But well, let's keep things simple. And for now, let's change the base units to English. This means that all the calculations, all the internal calculations in the program will be performed using English unit. The advantage is that the program doesn't have to manage many decimals, and it simplifies the calculation with the program. So base units, let's change English. The global axis, the direction of the global axis, the default is the Y global axis is the vertical axis of your structure. That's the default, and we recommend keep that default. You may ask why, and the reason is that many features the program depend on this configuration, depend on the vertical axis, and the vertical axis should be the Y axis. So some features can work. For example, the wind load calculation or the seismic load calculation. Those features require that the vertical axis is the global Y axis. Other thing, for example, if you want to change the background of the application, the default is white, but if you want to change it to black, that depends on you. And well, basically this is the main thing. The general things that we can change before creating a new model. There are other options like, for example, I can see the design codes. If you're looking for a specific design code, you can search it here. For example, for the steel structure, we have AISC 36020. This is the latest version we have, but there are other codes for different countries. And it's the same for the other materials. We can design steel members, concrete members, aluminum members, and timber members. But always check which codes are available for each type of material. But well, this is the most important parameters before creating a new file. Let me check back to English. Once you set up these parameters, we can click on the OK button, and now we can create a new model using this program. On the left side of the screen, we're going to go to the option, the red background, and then we are going to give a name to the new file, specify. Let's start. For example, let's say this is call it test 1, and then you have to specify the location of the file. You can click on the browse button and search for the folder where you want to save this. For example, I think I created a folder for your company. It is consolidated. I select a folder on my document. Do the same, save your model wherever you want, but this is mandatory. You have to specify a location to save your model. Then the program asks us which type of modeler we want to use. There are two options, the analytical modeler or the physical modeler. The analytical modeler is the traditional way to use STAAD Pro. STAAD Pro is a program that has been on the market for a long time, and well, the analytical modeler tries to show us the features and options and the graphic interface that the STAAD Pro program has used for many years. So that's why we call it like the traditional way to work with the program. The physical modeler is relatively new. It has like, I think, 8 years on the market. It has some advantages. It's easy to model. It's easy to model plates. It's easy to model slabs and walls. That's my personal point of view. That if you want to model walls, slabs, or any kind of a structure that requires a plate element or a shell element, the physical model is more appropriate to create that model. But personally, I think the best way to start is using the analytical modeler. Why? Because almost all the information that you will see on the internet, or the information that you can basically the information that you will see on the internet or on our website will be focused on the analytical modeler. And also the majority of the users that use STAAD Pro, they use the analytical modeler. So for that reason, and to the traditional way to work with this program, we're going to use the analytical modeler to create our model. In the end, it doesn't matter which modeler you use, you will get the same results after the analysis. You will get the same designs after the design of this. So it doesn't matter which modeler you use, but for the reasons I mentioned before, we are going to work with the analytical modeler. Is the traditional way. We will find a lot of information on the internet about the analytical modeler, and the majority of our users work with this modeler, the analytical modeler. Now we need to specify again the units. These are the units for the model that we're going to create. The previous units, the base units, are just for the internal calculations. These are related to the model that we're going to create. So I'm going to select English. I think those are the you will use. And then we have to specify two other things, like the title of the model, and if you want to use a seed file to create this new model. As indicated here, these are optional. There is no need to, I mean, if you don't want to give it a title yet or use a seed file, just ignore these options. Now we have to, I mean, this is also optional, but there is a section called job info. Here, when we click on this option, we have the option to enter a job name, a client name, and more information related to the project we are working on. Again, this is optional, and this is only important if you want to print a report directly from the STAAD Pro program. If you want to print the report that we offer, and you want to see your client name on that report or your name on the report, I recommend to enter the required information here. But don't worry, you can do this at any point on your modeling process. This is only if you want to add the information from the start. But we can enter this information later if needed. So for now, let's ignore this and let's click on the create button. It has a plus green sign, and once we click on that button, the initial window disappears, and now we will see the graphic interface of the analytical modeler. Okay, so at this point, does anyone has problems? Everyone is following what I'm showing you? The program is working well? Okay, perfect. We're going to graphic interface. Let's explain it very quickly. At the top of the screen, we have the ribbon toolbar. The toolbar is divided in tabs, the tabs with the red background. So we're going to talk about this later, but basically you can activate or change your commands by clicking on the icons in the ribbon. But let's go back to the geometry tab in the ribbon toolbar. At the center, we have the visualization window. Here we can see the global axis. As indicated, the global y-axis is the vertical axis of this program. X and Z are the horizontal axis. In this window, we're gonna see a graphic representation of the structure. So this window, we cannot close it. It will always be open. If I try to close it, the program tells me that it's not possible. We should always have this window open to always see what we are modeling, what we are entering to the information that we are entering to the program. On the right side of the screen, we're gonna see maybe one window, or we're gonna see multiple windows on the right side of the screen. The windows on the right side of the screen will allow us to enter information to the program, like loads, nodes, beams, whilst all the information that we enter on the program will appear always on the right side of the screen. On the left side of the screen, we have a workflow area. We call it that way. So basically, this workflow area is telling us that we can connect our structure with other programs. For example, if you see here, I can see a foundation design option. It means that I can model as an structure here in STAAD. And once I finish the design of the structure, I can click on the foundation design module and automatically connect this STAAD profile with a new STAAD foundation file. So uh, basically what we are saying here is that you can connect your STAAD Pro model to the applications on the left side of the screen in the workflow area. For example, foundation design, connection design, um, the RCDC program. Remember this icon, this blue icon with the white arrow is the same that we have here on your desktop. So this blue icon also appears on the left side of the STAAD Pro program graphic interface in case you want to connect your STAAD model with that application. Um, we're going to talk about this later day, but maybe in the following days. But for now, let's just say that all the icons on the left side of the screen will allow us to connect our model to other applications. And last but not least, we have a white bar here. This is going to be very important for us. The white bar. That white bar has 7 options. For example, I have selected the geometry option. See that the text changes to brown when you have selected an option from the white bar. And this white bar will help us um, to follow uh, a specific workflow, a recommended workflow uh, to maintain an order, to maintain an order to model a structure. Basically, we're going to follow this white bar from left to right. We're going to start with the geometry option. The windows on the right side of the screen, they show us the information of the geometry. For example, there is a window that tells us the nodes locations. We can see another window that tells us the beam formation. And that's because we have selected the geometry option in the white bar. If I select another option from the white bar, for example, let's say properties, automatically the window on the right side of the screen changes. And now it shows the cross sections or the thicknesses that I'm using to model walls or beams or columns. And so on. We can repeat this process. For example, I can click on the materials option in the white bar, and the window on the right side of the screen changes automatically. And it shows me the materials that I can use for that model. So this is going to be the design process that we're going to follow. We're going to start creating the geometry, select the geometry option in the white bar, and then we continue one option at a time from left to right until we reach the design option in the white bar. When we enter all the information for each step, we are going to be able to run the analysis and see the results. Another thing is that every time you click on one of these options in the white bar, the toolbar also changes automatically, and it shows us the options to enter the information for the required or for the selected step. For example, if I select the geometry option in the white bar, the toolbar shows me the commands to draw elements, to draw beams, to draw plates, to draw solids. If I select the loading option in the white bar, the toolbar shows me the commands to create a wind load, to create a new primary load case, and so on. So it's this white bar tries to simplify the modeling process, guide us through the whole process, to show us all the options, to enter the information at each step. So that's why we're going to use this white bar to create our models. So let's go back. Let's select the geometry option in the white bar to create the geometry of this first exercise. Here, please don't follow what I'm going to do. I just want to show you something. In STAAD Pro, we have 4 analytical members. And we're going to use a combination of these 4 analytical members to model structures. The first analytical member is the node. We are going to use a node to create the other 3 analytical members. Usually the nodes represent the corners or the connection between the corners of an element, the endpoint or the start point of an element, or they can represent the connection between elements. But well, we are going to use node. The second element, the second analytical element are beams. How can we model beams? Well, we use the commands in the toolbar, and then we click on the nodes that we created previously to model beams. The beam is a line, is represented by a line that we're going to use to represent columns, beams, braces, and basically that's it. These three elements: columns, beams, and braces. Then we're going to assign a property to that line, a cross section, maybe a W flange or a HSS cross section. But well, that's the second analytical member that we can use to create structures. The third analytical member is a plate. A plate is a analytical member that will allow us to model walls and slabs. Are the common use of a plate: model concrete walls and concrete slabs. We just define a surface. The program will generate a mesh. We're going to assign a thickness to that plate, and that's it. The program will consider the stiffness of those plates to create the stiffness matrix of. But again, the plates usually help us to model concrete walls and concrete slabs. The last analytical element that we can use is called a solid. A solid is give me 1 second. A solid is an element that we commonly use to design model and design massive foundation. As you can see, it's like a cube, and this is the only type of shape that we can use for solids. It's very similar to plates. It's an element similar to plates, but it has more advantages. Like we can simulate the behavior, the out of plane direction of a wall or an out of plane direction of a foundation. I'm gonna be honest with you. Yes, you can model solids. It's possible. It helps you to model massive foundations with a big big dimension in the thickness compared to the horizontal direction. But that is common. Common to use solids. Uh, of our users prefer to use plates, and we're gonna go with that assumption. If we need to model a wall or a foundation, we are gonna use plates instead of solids. Um, but well, I just wanted to show you that it's possible, but it's not common to model solids. And these are the four analytical elements that we can use in that. Node, uh, lines, plates, and solids. We will use lines to model columns, beams, and braces. We're going to use plates to model concrete walls and concrete slabs. Maybe you can use model steel plates. In case time you need to model a structure that requires steel plates, like a tank, like a water tank, or I don't know, a silo maybe. But well, it's up to you. You have to use these elements to create an analytical model of a real structure. Our objective is to uh, try to represent a real structure using these analytical members. How the structure will behave, how the structure will move using these members. And again, we can model solids, but we are not going to. So let me delete this, and let's start from scratch. Oh. Um, okay, before before we continue, um, before creating a model, check your input units. The input unit appears on the bottom right of the screen. You can see your base unit and your input unit. The base units appear as English on my machine. Double check that you can see the same on your computers. And the input unit appear as kip and inch. So that's why the geometry table shows me the node coordinates in inch. If you need to change the input units, you can do that anytime you want. For example, you can use an input unit to enter the geometry, and then you can change the input units to enter loads. So it's possible you can modify the input units anytime you want. How can we change those units? Well, in the toolbar, under the geometry tab, there is an icon that has the shape of a pencil and a rule. Click on that icon, and here you will see the available input. For the English system, we can enter lengths in or foot. So for simplicity, and because I'm going to create geometry, I'm going to change the length unit foot. The force, the default is kilopound, but if you want at some point, or if you prefer, you can change it to pound. Again, this is up to you, and you can change the input unit anytime you want. At this moment, I'm going to change to foot and kilopounds. I'm going to click on the apply button and make sure that you can see that change on the bottom right of the window. Now the input unit says kips and foot. And well, this is my recommendation. Every time you create a new model, verify the input units that you are using for this specific model. Before we start, we provided training material. We are going to follow that training material. The training material is is a zip file. I think all of you have this, or I think you should have it. We sent you a zip file that has 6 folders. Each folder represents one part of the training. So because we're going to start with creating geometry, make sure that you can see this folder, modeling structural members. And each folder has a PDF file that we call a workbook. That PDF file shows all uh, the workflow, the steps that we're going to do for this training, like the configuration of the model, the command that we're going to use, and we're going to build a model and modify it and more. So this PDF file is the workbook. It shows step by step what we are going to do today. The zip file that is in the same location of the workbook, zip file should have STAAD models, existing STAAD models. For this first part of the training, we don't have STAAD Pro models, so don't worry about this. For the other sections, we will see STAAD models, but for this initial part, there is nothing. We are going to build something from scratch. And well, this is what we're going to use for this training. You should see a folder, and each folder has a PDF file that is the workbook. It indicates step by step what we are going to do, where to click, which model to use, and more information. And the zip file should have STAAD models divided according to the unit, serial or metric. We're going to use serial. And here we will see our STAAD models. How can you identify the STAAD models? Because they have this format, .std. If you see a file with this format, it means that it is an STAAD Pro model. And if you want to open an existing model, and if you have the application installed on your computer, just go to the location of that model, double click on it, and the application will launch automatically, and you will see the existing model from the start. But well, for now, let's just start from scratch. Let's create a new model, a new geometry, and we're going to learn some techniques to model these structures. I'm going to use the workbook modeling structural members, and that's what I'm going to show you during the next hour. Let's start by defining, as I mentioned before, the nodes is one of the 4 analytical members that we can use that, and we are going to use nodes later model beams or plates using those nodes. The node usually represents the start point of a beam and the end point of a beam, the start point of a brace and the end point of a brace, or the corners of a plate. So that's why we need to create nodes. And the easy way to create nodes is using the table on the right side of the screen. Make sure that you have selected the geometry option, the white bar, and on the right side of the screen, you will see the nodes table. And I want to mention this from the start. Probably by mistake, you closed one window, or maybe the windows on the right side of the screen. Maybe you closed them by accident, or you moved them and you didn't know where is the window now. If that happens, if you lose a window, or if you close a window and you want to see it again, there is an icon at the end of the white bar that has the shape of 3 windows. It says restore view. We can click on that icon, and automatically go to the default view of the program. So make sure that if you don't see a window, click on this icon and you will go to the default view. So let's create nodes. It's easy. We have a table that shows us the 3 global axes, X, Y, and Z, and we can see the orientation of those global axes at the bottom left corner of the visualization, X, Y, and Z. So we can just enter the coordinates of the node. For example, I can enter a 0 value, the first cell on that table, and automatically I will see my first node located at this coordinate, 0, 0. And I can repeat that process to create more nodes. In this case, the node number 2 will be located 15 feet y direction. Then I'm going to create a third node located 25 feet in the X direction and 15 feet in the Y direction. And now I'm going to create a fourth node located 25 feet the X direction and 0 the other global directions, Y and Z. So I have 4 nodes now. I can start creating lines or plates. Because from using the simple things, I'm going to model beams. There are different ways to model beams. We can use the table on the bottom right of the screen. I just need to specify the node numbers that represent the start point of the beam and the end point of the beam. So for example, if I want to connect the node 1, the node 2, I just need to enter here the information. I just want to create a beam that starts from the node number 1 and that beam ends at the node number 2 location. And that's it. See how the beam appear on the visualization window. And we can repeat this process. Now we can connect, for example, the node 3. And it's simple, but if you have a lot of nodes, maybe it's difficult to find the node numbers. So one thing that could help you is to see on the screen the node numbers. Every time you want to see more information in the visualization window, like the member sizes or the load values or the load diagrams, or whatever you want to see on the visualization window, you have to go to the View tab in the toolbar and click on the first icon. The first icon will open a new dialog box that will show you all the possible things that you can turn on in the visualization window. So for this example, I want to see the node number. So I'm going to go to the Labels tab, the Diagrams window, and click on the node number option. Activate the node number. And let's say that I also want to see the beam number. I'm going to turn on the beam numbers as well. I'm going to click on the Apply button, the dialog box, and automatically you will see the node numbers and the beam numbers on the screen, the visualization window. If you don't want to open this dialog box every time, you can use some shortcuts. If you see here, there is a letter parentheses for some options. So you can use the shortcut Shift plus the letter parentheses and automatically turn on that information, the visualization window. Let's try it. For example, the node numbers. There is an N letter parentheses, so I can close that window. And now with my keyboard, I'm going to press the Shift key and then the N letter and see how the node numbers appear. I can repeat that shortcut, Shift plus N, and the node numbers will appear again. So that way you don't have to always open the label settings window. And well, once you can see the node numbers, maybe it's easy to fill or enter the information in this beam table. For example, let's say that now I want to create a new beam that starts at the node 4 and ends at the node 3. So I can enter the node numbers in the table and automatically create the line, the visualization. This is the simple way. Create the node table, and then you use the table below to create beams. There are other options. For example, you can manually draw the line. For example, you can go to the Geometry tab in the toolbar and then click on the Add Beam icon. It has the shape of a tube and a plus green icon. When you click on this, you'll see a beam next to you. And with you can click on any node in your model to specify the endpoint and the start point of your beams. It's a graphic process, and I think it's simple. With your cursor, you can click on existing nodes to create beams. So now let me show you other modeling techniques. Let's say that you want to copy elements, that you want to make things easier, and you want to maybe make copies of your existing elements in the visualization window. What you can do, well, first you need to deactivate the beam command. I can still see the beam next to my cursor, so I'm going to click on the escape key on my keyboard to deactivate commands. See how the beam disappeared, and now my cursor is just the cursor. And now let's say that I want to copy lines, that I don't want to place nodes and then create the beams. I think that's time consuming and I want to speed up the modeling process. Okay, if that's what you want, if you want to speed the modeling process, you can copy existing elements. For example, I'm going to select the vertical lines and the horizontal line. Press the Control key on your keyboard, and that way you can select multiple elements without losing the previous selection. And if you want to deselect an element, click again on that line, deselect it. Have selected the beams that you want to copy or the lines that you want to copy. You'll see them in red, and then we can use the copy commands, the toolbar under the Geometry tab. For example, let's start with the translational repeat option. In the toolbar, there is an icon like the shape of a rectangle with vertical stripes. The name of the icon is translational repeat. Let's click on it, and a new dialog box will appear. In the dialog box, we have the option to create copies in the 3 global axes. That's the first question. Where the direction of your copies, X, Y, or Z. We need to select one of those. I'm going to select the Z direction. And then we need to specify the default spacing between copies and the number of copies. So let's say that I just want to create one copy, number of steps 1, and the spacing between copies, let's say minus 30 feet. The negative value tells me that the copies will be placed in the opposite direction of the global Z axis. Copies will appear behind my existing elements. Additionally, we can tell the program if we want to renumber a bay. This is not common, but this is The next one is useful if you want to link your copies. This means that every node of your beams will create a cross line to connect the next copy in that direction. That's what the link. And if you don't want to copy, if you don't want to create a cross line at the base of your columns, you can tell the program that do not link the nodes at the base of your columns by activating the open base option. Let's see how it works. I'm going to select these two additional options. I'm going to create a copy in the global Z direction. The spacing is -30. I have all I need. I just need to click on the OK button, and we will see the information on the visualization window. See how the program created these transfer lines to connect the new copy. And we didn't create a copy at the bottom because we selected the open base option. So these copy tools, those are useful. They can speed up the modeling process in case you need to model a complex comet. Now let's talk about other options model beams. For example, let's say that, okay, I don't have a node and I need to create a beam that starts at the midpoint of an existing line. If that happens, if you create a beam and you don't have a node, but you have a line as a reference, we can use other tools to create that line. For example, in the or below the add beam command, there is an arrow pointing down. We can click on that arrow and we can see more options to create lines. For example, let's say that I want to use point, create lines. I click on that option. See that my cursor has a beam image again, and I just need to click on the lines, and automatically the program will know that I want to create a beam at the midpoint of the selected line. Let's try it. For example, I'm going to click on this column. See that there is no node here, but the program identified the midpoint of that line, start the beam. And then I can do the same. It doesn't matter where you click. For example, I'm going to click maybe to the corner, but because I have selected the midpoint command, the program will place the endpoint of that beam at the midpoint of the selected line. This could be useful if you want to model beams without creating the nodes. I can repeat that process. For example, on this other column, I just need to click on the line. The program identifies the midpoint, and I can click on another line, and the program identifies the midpoint to create the beams. Okay, and now let's say that, okay, we made a mistake that we didn't want to model this beam, and now you need to delete it. Okay, there are different options. For example, the most common, like an Office application, you have an undo command, an arrow pointing to the left at the top of your screen. You can undo your last command. You can click there and see how the beam disappear. Another way to delete, and you can redo. There is an arrow pointing to the right to redo the last command. There are other options to delete beams. For example, okay, first of all, I want to deactivate the beam command. Click on the escape key on your keyboard to deactivate the command. And if you want to delete something, select it with your cursor and click on the delete key on the keyboard. The program asks us we want to delete it. Let's say yes and continue. But now we have a new problem. because we created a beam and the program created nodes, model that beam. Now the existing beams are divided in segments. So this could be a problem because, well, maybe if we want to design this, we will get a design report for each section, for each line. And maybe to simplify it, we just want one design report for the whole beam. So what we can do is merge lines. How this works? Well, we're going to select the lines that we want to merge. The lines have the same direction, or they should be in the same orientation. Remember, hold down the control key to select multiple elements. And once you select the beams that you want to merge, we can go to the toolbar and select the icon that says merge selected beams. It has the shape of white flame. We click on that icon. The program shows us the numbers of the beams that we want to merge. And we just click on the merge button to proceed. And see how the node disappeared. And again, the line is just one element. So we can repeat this process for the column. Hold down the control key, select the two elements, go to the merge selected beams icon, and then click on the merge button. Repeat this process. Another tool that could be helpful is divide a member. Let's say that I want to add secondary beams, that I want to model beams parallel to the X direction. And I need the nodes. I need the nodes to create the beams. So what I can do is select the elements that I want to divide. For example, these two lines. Then I can go to the toolbar and select the insert node command. When I click on that command, a new dialog box appears and asks me the position of the new node. We have different options. For example, I can add a new node by specifying a distance. The distance is from the start point of the line, the distance that I enter here. But well, this is a tool that could be helpful in some cases. There are other options in case you don't want to, that you want to create a node by proportion. What's like a fraction of the total length of the beam. A proportion of 0.5 is the midpoint, or maybe if you want to enter a new node at 1/4 of the total length, you can enter a proportion of 0.25. But again, this is that can help you depending on what you want to model. For simplicity, I'm going to specify any number of nodes, any number of new points. I just need to enter the number of points, and the program will place the points equally spaced along the beam. So for example, let's say that I want to create three nodes. That I want to create 3 nodes equally spaced for each of the selected lines. We enter those nodes, the number of points, sorry, and we click on the OK button and see how the program created 1, 2, 3 nodes for one of the beams and created other three nodes on the other side. And now that I have the node, I can create the beams. I can again go to the toolbar, the add beam from node to node command, the icon with the plus green sign, and click on the node to create the new beam. Again, this is something that I mean, this will require some creativity to speed up the modeling process. Which command is better for what you want to do to model your structure? Well, I'm just showing you the tools to create geometry. Then you will decide which one is more appropriate for you. Another interesting thing in this program is the, oh, sorry, I didn't mention this, but you can use the arrows. You can use the arrows of your keyboard to rotate the view. Move the arrows to use the left arrow or the right arrow of your keyboard to rotate the view. And you can do the same for the vertical direction. Rotate the view with the arrows. Another interesting thing in this program is that you need to create a node, a common node, tell the program that the members are connected. What does, okay, so let me click on the escape key on my keyboard, deactivate the beam command. And let's talk about this beam, the braces. With this modeling technique, the braces are not connected. They are not connected at the center. Why? Because there isn't a common node that connects the beams. So in this modeling, this model, I'm telling the program that the brace is just connected from the top of the column to the bottom of the other column. And it happens the same for the other brace. It starts here, it is connected to the column, and then it's connected to the other column. But the braces do not share a node and they are not connected at the center. Again, this will depend of what you want to model. If this is correct, if this is what you want to represent, we don't have to do anything. We just leave the model as it is now. But if you want to connect the braces, we need to create a node, a common node, and connect the braces between them. So one thing that, oh, and sorry, I didn't mention this, but you can use the wheel of your mouse, zoom in, zoom out, or you can press the wheel and pan the view. It's like a CAD program. Manipulate the view. So let's say that you want to create a connection, that you need to create, that you want to connect the braces. What you can do is first tell the program to detect all the intersections within members that do not have a node. This is an automatically detection. We can go to the beam tool, to the toolbar, select the icon with the cross. The name of the icon is intersecting beams. I'm going to click on that icon and we will see two options. One will highlight the intersecting beam and the other will intersect the beams. So we could say that the first one is just identify the elements in our model that are the same plane, but they are not connected. Let's try it. Let me click on the highlight intersecting. I need to enter a tolerance. Let's keep the default. I'm going to click on the OK button and see that the program automatically highlighted the braces. Why? Because they are crossing members. They are crossing each other, but they don't have a common node. So they are not connected. Once you identify the members, and if you want to connect them, we can use the second option. We go back again to the ribbon, click on the cross icon, and then select the intersect selected beams command. Again, the program asks us for a tolerance. Let's go with the default. Click on the OK button, and then the program tells us that two new beams were created. We click on the OK button, and now we can see the difference. Now there is a new node at the intersection point, and we have 4 lines instead of 2. This is how we model a connection between elements. And this is very important because this can impact the behavior of your structure. So make sure that you model every connection correctly, create the nodes, create a common node, transfer transfer forces or to transfer stresses between the lines. So let's say, for example, that you want to model a horizontal brace for the platform. We can do that. We can model a new beam from one corner to the other corner. And usually this, click on the escape key to deactivate the command. And usually this modeling, for example, for industrial structure, the braces are placed below the beams. They are not connected to the beams. Say that this modeling technique is correct. The brace goes from one top of the column to the other top of the column, but it is not connected to the horizontal or the cross beams. So again, you have to use these techniques, model the behavior of your real structure. What else? Let me see. Okay, and we have seen different options to create nodes, create lines, use the tables on the right side of the screen to create the lines or create the beam. So now let's say that, and we have seen the option to create copies, the translational repeat copy command. So these are options or commands that the program offers you to speed up the modeling process. Another, yeah.
Hey, can I just ask a quick question?
Yeah.
For back on node 17, is it possible to release the, I guess I want the stresses, I don't want the stresses, I want 145 and 164 to be to see this. I want node 17 to lock in displacement and translation, but not transfer stresses. Is that possible to kind of just set it as a displacement node, not as a stress node? Like, so 145 and 164 would be a continuous beam, and then 165 and 146 would be continuous, but they would be locked together at node 17. So when they move together, but the node would just be a shear connection. It wouldn't be a moment connection.
Yes, it's possible. We're gonna see that later when we reach this step in the modeling process, the specification option, the white bar.
Okay, that works.
But,
okay, thanks.
But yeah, we will see that later. And well, we are still modeling geometry. Another tool that could help you to model geometry is using templates, like typical structures we have added to the database of the program. And maybe you want to use one of those templates to create your geometry. And we can access the database by clicking on the structure wizard icon, the toolbar. For example, let me click there, structure wizard, and a new window appears, and we will see the templates on the left side of this window. The templates are divided by type. For example, there is a drop-down menu here. We have truss models, and we can see different options, or we can change it to frame models. And again, the left side of the screen give us different options to create frame models. And this also applies for plates. For example, let's say that I want to use a plate model, and I don't know, that you want to model like a cylinder. You select the model type that you want to use, double click on it, and by entering a few parameters, we're going to create a more complex geometry. For example, for this cylindrical surface, the length 10 feet, the radius at the start, the end radius at the end of the cylinder. Let's go with the defaults, and let's click on the apply button, and the program will show us a preview of this of the geometry, like a cylinder created with plates with a specific dimension. And again, this can help you to speed up the geometry creation. We could change it. We can go back to cross models, or no, let's say frame models that you want to model a building, and we can double click on the base frame icon, double click, and then specify the parameters of the tree. Let's go with the default. 4 divisions in the length direction, 5 divisions for the height, and 4 divisions for the width. So let's click on the apply button, and we can see the geometry of this template. So to be honest, these are very simple templates. Probably you won't find what you're looking for exactly, but again, this could be a starting point. Instead of creating copies or placing nodes in the visualization window, you can use one of these templates to start your model and then modify or create more copies or the lead lines or whatever you need to create your job. It's impossible to show you all the available templates, so I'm just gonna say that you look the options. Remember, you have to on the left side uh, see the drop-down menu, see the options, and pick one from the options. Double click on the template that you want to use. For example, I'm gonna go with North Light, and I think this is part of the workbook. Yeah. And let's say that. Give me 1 second. I think is okay. Let's say that I want to model a truss like a North Light truss with 25 feet as the length, the height, let's say 10 feet, and the width, let's say the number of bays along the length, let's say 4, and the number of bays along the width, let's say 0. Once you enter these parameters, we can click on the button apply, and we will see a 3D or a preview of the structure. Let's say that I agree with this geometry, that this looks fine for what I want to model. And now I need to bring this structure to the STAAD Pro analytical modeler. How are we going to do that? Well, in this window, we are going to go to the File menu and then click on the option that says Merge Model with the STAAD Pro model. Click here, and the program asks me if I want to proceed. I'm going to say yes, and then it will ask me where do I want to place that structure that I created in the structure wizard. So let's say that I want to place it here at the node 3. I didn't mention that, but the template has a reference point. I think the reference point of the truss is the bottom left point of the truss. We'll see it in a moment. But well, let's say that I want to place it here on the node number 3. The bottom left corner of the truss will be placed at the node 3. And I don't remember the coordinates of this node, but let's say that by distance, okay, in the X direction, I think it's 30.
I think it was 25, 15.
20, 25, and 15 in the Y direction. Okay, this is gonna be my insertion point, and I'm gonna click on the OK button. And the program is telling me that it identified duplicated nodes, so that's okay. let's the program ignore the duplicated nodes. We click on the OK button, and now we can see the template that we created in the structure wizard, and we bring that into that model. And see how the reference point of the template was the bottom left of the truss. Again, this is another tool to speed up the geometry creation. Let's play with other tools. For example, let's say that you want to, there's another way to copy beams, to copy lines, like in Microsoft Office applications. You can copy and paste. For example, I can select a beam. If you want a copy, there is a copy command. There is a cut command and there is a copy command in the toolbar. These commands are like Microsoft Word, Microsoft Excel, where you copy and paste elements. So let's say I want to copy, click on the copy command, and now I want to paste that beam. So in the toolbar, there is a paste icon. I can click there, and a new dialog box will appear that asks me the location of that copy of the beam that I copied earlier. So from here, I don't know. Let's say, let me try this reference point. Oh no, forget it. No. Do not use this option. So let's say that I don't know. Like I want to copy that beam to node. Okay. Now let's say that I want to place that beam here for the node 15. I think that node is located, X direction is 25, Y direction is 15, and Z direction is 15 again. I place the position of the paste, and then I click on the OK button. Oh, didn't work, but oh, okay. Sorry. The new copy was placed 25 feet in the X direction based on the initial position of that copy. For example, let me try that again. I'm going to delete that beam, select that line, delete it with my delete key on my keyboard, and let's repeat the process. Select this line. I want to copy. I click on the copy command in the toolbar, and then I click on the paste command in the toolbar. And this time I'm gonna place it, let's say 10 feet in the X direction. If I'm okay, the new copy should appear 10 feet from the original distance of the selected line. Let's click on the OK button. Yeah, and we can see here that a new line appeared 10 feet in the X direction from the original line. So that is another way to copy, more like again, like an Office, like a Microsoft Office. Another way that we can do this is you also have the cut command. For example, I don't know the location of this or the distance between this and this. Let me show you another tool. Let's delete this. Let's delete this line. Going to delete it. And sometimes like this, like I want to know the distance from the node number 3 to the node number 21. We can use a command to check that distance. You can go to the utilities menu at the top of the window. Then we can go to the node tools option, expand the menu. And from here, we can use the node to node distance. I click on that option. See that now my arrow has my cursor has a dimension image, and now I can click on my visualization window and see the distance. For example, from node number 3 to node number 21. Oh, well, we have a lot of information here, but I can see number 25. that I have 25 feet from this node to this. And the beauty of this tool is that you can check the distance from any two nodes you want. For example, from the base of this column to this point, 32 feet. You just need to select two nodes and the program will give you the distance from node to node. It's very useful in case you want to check dimensions model. If you want to delete the information, if you want to delete this dimension, we can go again to the command and click on the remove node distance option, and all of them disappear. So now that we have identified the distance from this point to the other point, I can copy that beam. I can select the line. I can go, let's say, again, copy and then paste the tools in the toolbar and place the new copy 25 feet in the global X direction. Click on the OK button and the new beam will appear the visualization window. Now let me show you other tools. Oh, this is going to be very useful. Let's say that you want to select a lot of beams or a lot of elements by drawing a fence. So in STAAD Pro, it's kind of tricky. Drawing a fence to select elements is it depends on how the length of the element within the fence. If you, for example, if you just for example, let's say that you want to select this beam 147. Draw a fence that covers more than the half length of the element to select it with the fence method. If you just draw a fence and just enclose a very small part of the line, nothing will happen. So again, it's tricky, but the idea of the fence method is that you have to cover more than half of the total length of that line to select it. A fence and do something like this, I don't need to cover the whole length of the member. As long as I cover more than the half length, the program will select that member. So again, this selection tool help you select multiple elements and then manipulate whatever you want to manipulate. But well, once you select these, let me try it again. Once you select the members, I'm going to delete them. Delete the red elements. Click on the delete key on my keyboard and click on the OK button to proceed. And now I just have this truss geometry. I wanted to do this because I want to show you other commands. For example, the mirror command. Let's say that I want to create a mirror. I want to copy this side of the truss to the left side, and that we need to know a few things about our model first. For example, we need to know the location of the rotation axis, or the axis that represents the location of the. How can I know that? Well, first I need to identify, for example, let's say that this node is going to be my reference point, the node number 4. On the right side of the screen, I can search that number on my table, and I can see that the node is located 20 feet in the X global axis. So now I can create my copy. I'm going to select all the lines in my model. Then in the toolbar, I'm going to go to the mirror command. It has the shape of 2 squares and an arrow pointing both squares. Click on that command and a new dialog box will appear. The parameters in this dialog box, we're going to create a mirror copy a copy. First, we need to specify the mirror plane. By default, is the YZ. It's like a well, you can see the global coordinate system here, the Y and Z axis. It's like you're placing the mirror on that plane, and then you have to specify the location of that mirror. In this case, I want to place that mirror at 25 feet in the X direction. So my mirror is located here in the node 4. And then I have the option to move the selected elements, or if I want to create copies of the selected elements. So let's say that I want to create a copy, and then I'm going to click on the OK button. We will see, oh, and again, the program warns us that there are duplicated beams, and it asking me if I want to generate the duplicated beams. Why? Because these vertical lines in the node number 4 at the X in the 25 feet direction. So because I selected them, the program wants to create a copy of them, but because this is my reference axis, I don't want to create the copies. So I'm gonna say no, I don't want to create duplicated beams. And now you will see the new elements created using a mirror command. And now we're going to another tool. Let's say that you want to create copies, but this time not as a translational copy, not as a copy in the X or Y or Z direction. This time we want to create a copy based on a rotation point, like creating circular copies, something like this. Let me show you this image. Let's say that we are modeling this front part of the structure, and we want to create circular copies, all of them rotating around one common axis. So the idea is that we need to select the elements that we want to copy. In this case, the left side of the truss. I just need to select these elements. I don't need to select the central column because I don't want to create duplicates for that column. Once you select the elements that you want to copy, we're going to go to the toolbar and we're going to select the circular repeat command. It has the shape of a circle. Let's click on that command. A new dialog box will appear, and we need to specify the location of the axis of rotation and the number of copies that we want to create. For example, the axis of rotation will be parallel to the Y global axis. That's okay. Now we need to identify the position of that axis of rotation. The X coordinate will be 25. Remember, the node 4 is located at 25 feet in the X direction. And the Z coordinate is the 0 feet. This node 4 is located at 0 feet in the Z direction. So now we have, or well, you can specify the node number and save you time instead of entering the coordinates. It's the same thing. If you prefer to enter a node or if you prefer to enter the coordinates, both options will give you the same results. Once you identify the position of the axis of rotation, the direction of the axis of rotation, now we just need to define the number of copies. So let's say that I want to create copies only within 180 degrees. And I want to create, let's say, I don't know, 6 copies in this angle limit. With this information, we can also tell the program to link the steps. Every copy will have beams connect the nodes of each copy. And as we did for the translational repeat, we can tell the program that we don't want to create copy link elements for the bottom of our columns, and select the open base option. Once you enter all the information, we can click on the OK button, and the program will do the rest. Oh, well, it made the copies in the other direction. Let's say that you wish to generate. Okay, again, we have duplicated beams. I think it's because the last copy in the process, but I don't want to duplicate beams, so I'm going to tell the program to ignore the duplicate beams, do not create duplicate beams. And using the arrows on your keyboard, you can see all the copies and see how all the copies have links. These lines are the links that connect one copy to the other. And we don't have links at the bottom because we selected the open base option. So these are more advanced, let's say advanced techniques to create circular copies or create copies using a mirror plane. Now I'm going to show something interesting. As you can see here, we have a lot of lines, we have a lot of information, and this is very common in STAAD. It's very common to have these overlapping members, overlapping information, and this makes it difficult to select a specific line. For example, let's say that, I don't know, I want to select something here and see how automatically the program selected 3 lines. Why? Because they are very close to each other. The program doesn't know which line you want to select, and it selects the 3 at the same time. So this is always a problem. This is creates problems to select members. What you can do, you have this kind of cases, this kind of a structure where it's very difficult to select a specific line. We recommend creating groups. We recommend to select a group of lines and assign a group to them. That can help you to later filter the view for a selected group, or yeah, you know, something that can easily help you to select a specific element in. Create groups, we need to go to the utilities menu at the top of the window, select the groups option, the toolbar, and then we're going to create a new group. For example, I'm going to call these columns. The group name is columns, and then I need to specify what type of analytical member will be part of this group. I can create a group of beams, only lines. I can create a group for a geometry. Geometry is like creating a group that contains lines and nodes at the same time, or maybe lines, plates, and nodes at the same time. And there is a 4th type of group that is floor. We will see that later. This can help us to apply floor loads. That's the objective of this type, apply floor loads, but we will see that later. For now, let's say that I want to create only a group of beams, only lines without nodes, only the lines. I'm going to click on the OK button, and I have created my first group. It is called columns, and it is a group that will only accept beams. In other words, it will only accept lines. Now that you created the group, select the elements in the visualization window that will be part of that group. I can draw a fence, cover almost the whole length of the column. Remember, you don't need to select to enclose the whole length of the member. You just cover more than the half length of the element. Draw a fence, cover almost the whole column. Once you select the columns, they will turn on red, and then And then we can click on the associate button. Click on the associate button, and now we'll see the list of all the beams, the beam numbers that are part of the columns group. And I can repeat this process for the rest of the structure. For example, I can create another group. I can click on the create button, and this time I can call these I don't know, let's say truss. The type, I'm going to change beam. I'm going to click OK. I have a second group, and let's say that I want to all the members at the top of the structure will be part of the truss. I select them, select the group, click on the associate button. We will see the list of beams that are part of the group, and we can continue and repeat this process the number of times we want. The idea is that you can create groups that can help you to select specific members. For example, maybe you just want to create a group for the diagonals. I can select the diagonals of this cross, and I can go to create. Let's say diagonals. The group type is going to be beam. Click on the OK button. We have created the group. We have the elements selected. We just need to click on the associate button and see how the number of beams appear in the group. So this is interesting. One beam or one line or one node can be part of multiple groups. You can, yeah, one line could be assigned to different groups. For example, the diagonals here are assigned to the truss. For example, I can select the group, click on the highlight button to see the members assigned to that group. We can see the diagonals, but we can select the group number 3, click on highlight, and we can see again the same elements that are part of another group. In the end, we are doing this just to help us select lines when we have these type of scenarios where we have a lot of lines that it's getting difficult to select on a specific line. What's the advantage? That then that we can create views, that we can filter the view and just modify the information we are interested in. For example, let me show you. I'm going to go to the View tab in the toolbar. And here I could, I don't know, let's say that that I want to see a top view of the structure. So using the cubes at the center of the toolbar, I'm going to select the top view. And now with my cursor, I can draw a fence, and all the elements that are covered more than half of their length within the fence will be selected. So see how here I have selected these elements. And let's say that I want to apply a specific load to that lines, and it's getting difficult to work with a view that contains all the lines. Select the members and use the selected objects option bar, and the unselected members will disappear, and the window will only show the selected members. Then we can rotate the view using the arrows on our keyboard. Oh, using the arrows on our keyboard, and with a view with less elements, we can start manipulating the model. Maybe I can add a load only to this line, or maybe I can add a load only to this line instead of having a view with multiple lines that makes this process difficult. So the selected objects tool, you just need to select the element that you want to modify. For example, these 2 lines, and then click on the selected objects icon. And the view will only show those lines. If you want to see again the full view of the structure, you can go to the display whole structure icon, And again, you will see all your elements in the visualization. Why we want to create groups? Because it makes easier to select lines. For example, here under the View tab in the toolbar, I cannot see all the icons in the toolbar, but there is an icon called Windows with an arrow pointing down. You can click there, and here, choose structure only tables. No, sorry, it's not here. No, it's not here. It's we need to go to the select tab in the toolbar, and then we can go to the where is it? Oh, attribute. You can go to the attributes option in the toolbar, select the group option. You will see all the groups in your model. You can select one or multiple groups. For example, let's say diagonals, that I want to select the diagonals. See how the program highlights elements that are part of the diagonals group. And once you select them, you can go back to the View tab in the toolbar and then apply the selected objects view. And this can help you a lot to filter the view and just edit the elements that you are interested in. What else? Okay, there are other options. I'm going to display the whole structure again. We can create views. Let's say that again, you want to modify a certain number of elements in your model. So let's say that again, I'm going to change the view to a top view using the blue cubes under the View tab in the toolbar. I'm going to do a top view, and with my cursor, I'm going to select again this line of elements. Once I have selected the elements, I can once I have selected the elements, we can create a new view only for the selected elements. There is an icon in the toolbar called View. Click on that, and a new dialog box will appear. It asks me if I want to create a new window for the view or if I want to display the view in the active window. The active window is this one, test one. So let's say that I want to create a new window, the first option, for the selected elements only. Select this option, click on the OK button, and see that this time I have two windows for the graphical appreciation of this. One that is called whole structure, and the other one that doesn't have a name yet. It says untitled. But this helps me also to filter the view, to filter the elements, and work with only these elements and ignore the rest of the structure. And why this is helpful, it's because it's easy to manage, it's easy to edit a model with less lines. And let's say that okay, we have created the view, but I want to use it later. I want to use it tomorrow or at the end of the week. That I want to analysis, and then I want to see this view. They see the results for these elements. So if you want to save a view, once you have created a new one, we can go to the toolbar again, and this time we're going to go to the view management icon and click on the Save View option. Let's click there, and the program tells us that we need to specify a name. See that right now it says untitled, but let's say View 1, give it a name, and then click on the OK button. And see how the title of the window, now it says View 1. And this view will be part of your model. Every time you open this model, the view will be available for the selected elements. Let's say that I close this window I want to open it again. I don't need to select the elements one more again. I don't need to repeat that process. I just need to open the saved view. In the toolbar, I can click on the open view icon, and the dialog box will show me the saved view, this model. I'm going to select the only view that exists and create a new window for the selected view. Click on the OK button and see how now the view is part of the model, and every time you open the model, this will be available. And well, let's close it. And basically, this is what we show in the in this first part of the training: how to create geometry, beams. Another thing, this is extra. What I'm going to show you, it's extra in case you want to consider this method as an alternative. Let's say that okay, let me delete this. I'm going to select all the lines, click on the delete button, and let's say that you have a CAD drawing, that you have a drawing with lines that represent columns or that represent braces and beams. So in those cases, if you have a CAD drawing, you can save that drawing as a DXF file. Let me show you an example. I'm going to show you a CAD drawing created with MicroStation. MicroStation is the CAD program developed by Bentley Systems, but this works for AutoCAD or for any other CAD program. Okay. Give me 1 minute. I just want to show you the drawing, the CAD graphic interface. For example, let's say that that you have this kind of drawing, a drawing with lines. Oh, and this is important. All the lines in your CAD drawing should be single lines. We cannot import polylines into that. We can only import single lines. But well, let's imagine that you have a CAD drawing. It could be a 3D drawing, but you need to only model single lines. And with this type of format, you can save it as a DXF file. That's important. It should be a DXF file when you save the model. Save it as a DXF, and once you have that file, STAAD Pro, you can import that DXF file. You can go to the File menu. On the left side of the screen, click the Import Export option. Here are the typical formats that we accept: DXF, STP, and basically those two, DXF and STP. In this case, I want to import a DXF into that. So let's click on the DXF option. Okay, I'm going to click on yes to save changes. And then I need to find the DXF drawing on my computer, the file that I want to import. In this case, the beam1. But I need to close the CAD file first. Give the name beam1.dxf. I'm going to close it. Now I can import it into STAAD. Select the beam1, click on the open button. And before importing the file, it asks me, do you want to change the global axis? Probably the CAD program has another orientation for the global axis, so this could be helpful before importing the model. But let's say that I don't want to change anything here, and let's click on the OK button. I need to specify the units, like how the program will convert the units from the DXF to the units in STAAD. So let's say that I want to see the units in foot, and well, actually, because this is a DXF, the only units that matter are the length unit. So let's click on the OK button, and process could take time depending on the complexity of your CAD on the DXF drawing. And once we finish, well, we can see the lines and the nodes in the visualization window. And the tables on the right side of the screen already have all the information of the DXF drawing. These things may happen. For example, these three lines do not exist in my DXF drawing, but I mean, doesn't matter. I can select them and delete them with my delete key on my keyboard. But again, this is another tool to speed up the creation of the geometry. We have seen a lot of tools. You can decide which one is better, which one you find more suitable for your projects. If you want to use the program graphic interface to create the model, that's okay. If you want to import the XF drawing, that's also okay. If you want to use the wizard, it's okay. This is only geometry creation. In the end, doesn't matter which tools you use. If you model the same geometry with the different tools, you will get the same results at the end of the design process. And well, this is everything for the first part of the training. We have learned how to create nodes, how to model beams. It is not included in the tool. We're not going to model plates, but in case you are interested in modeling plates, I'm just going to show you one easy way to do that. How to generate mesh very easily. Under the geometry tab, we can go to the generate mesh option, select the create mesh option. See that now your cursor has like a table, like a plate mesh image, and now you just select a minimum of 3 nodes on your model. You can select more than 3. You can draw a polygon in the visualization window. That's up to you. But a minimum of 3. Select 3 nodes in your model. Click again on the point when you started the figure. A new window will open that will ask you the number of divisions, on each side of your figure. There is an option to add holes, but well, let's keep it simple. Let's say that I just want to create a boundary, a full plate with the perimeter of the selected node. We can see the preview of the image here in the dialog box. And once we select the number of divisions per side of the triangle or the polygon, we can click on the OK button. And that way you can model plates. Very easily, the program does the mesh for you. And this way you can model concrete walls or concrete slabs or steel plates. But that's all that we're going to see about plates. Plates is not included in the course unless you want to learn this, but you can tell me that later. Okay, I think that's all for now. I think you know how this is going to work. We have scheduled a 5-hour meeting. We're going to learn something within the first 2 hours. Then we have a 1-hour break. And then we continue after that break for another 2 hours. We're going to repeat this methodology for the next 3 days. We start with a 2-hour presentation. We have a 1-hour break, and then we continue for the afternoon. So thank you. And go ahead, Said.
Yes, thanks for the presentation. I have few questions. I know we are at the very beginning stage of the training. But I would like to know that can we do a proper building design using the STAAD Pro? We have the steel structure, wheel metal deck, all the beams are composite. We have the spandrel beam all around the building. So I understand this kind of analogy, you could you could do the analysis of the truss, of the frame, but when it comes to a proper structure, you want to do all the beam analysis, all the column analysis, the metal deck analysis, the composite beam analysis. Can this
Okay.
software handle it? And do you have a sample of it?
Yes, we can design composite beams. But the design code is well, could be a problem because it handles only an old design code for composite beams. We can see that later. We can see that later in the we get to the analysis and design part of the of the but oh well, in a few words, the answer is yes. The program can do that, but using an old version of the AISC code.
Okay, good to know. Yeah, I'm looking for that because, we try to really use this new version of the STAAD Pro for the new building design. And I just want to make sure that it's practical, using this software. And we need to also go over with, I know we are at the very beginning of the presentation or training, but mainly how we could prepare a very professional analytical report from this
Oh,
model. That's
okay,
also another, item I would like to focus on. But
okay.
okay, yeah. So thank you very much for all the input or however you are presenting it. But I just want to give you some heads up that that's one of
So,
the item I am looking for.
okay, got it. And I
Thank you.
will note that. I will write that down, and we will see that during the design presentation.
Okay.
And thank you. I'll see you in 1 hour. It's the same link. I mean, you can keep you can stay in the meeting and well rejoin. Well, stay here. Do not leave the meeting, and we will start in 1 hour again. And thank you. I will be here. Oh, and if you want to write something, if you want to add comments, you can use the chat of this window and type your comments. Hello, hello. Is someone there?
Hello.
Okay, okay, perfect.
Hello.
Yeah, I think we can start again because otherwise we are not going to see everything. So let's start before and well finish the second part of the day talking about properties, how to assign properties. So let me share my computer screen again. Here you can see the model we were using during this morning. But well, let's close this. I'm gonna close it, and I'm gonna save changes. Anyways, we just learned different options, different commands to create geometry in STAAD Pro. You can use one or two or more options that that we saw to build your models. Uh, choose whichever is better for you, the one you feel more comfortable. Uh, and well, this is only about geometry. So it doesn't matter if again if you build your geometry by creating nodes and then joining with lines, or if you create the same geometry using the structure wizard. Uh, Everything is the same. This is just to create geometry. Uh, Now we're going to talk about assigning properties to the structure. Uh, the training material we sent you included one folder to assign properties. The name of the folder is assigning properties. Open it, and here you will find the workbook. Again, the workbook is the PDF that explains step by step how to assign properties. And for this second part of for this afternoon, we are going to use existing STAAD models. So I hope you have this information. If you don't have it, I can send you a link to download this this training material. But well, for now, I'm assuming that all of you have this information. So inside the assigned properties folder, we will find two uh, two more folders, an imperial and a metric folder. Let's open the imperial folder, and here we will see the STAAD models. Oh, yeah, go ahead, Said.
Yeah, I don't have it. Sorry, I don't have this stat file.
Okay, give me 1 second. I'm going to
Um,
send you.
I had Marco attached it in a link in the Teams or in the email he sent out this morning, and I think it's also in the Teams invite. If you click the link, you can download a zip file.
Okay,
Yeah, I
let me.
downloaded it, but I don't see it actually. That date, I don't know. Am I missing something? I don't have that stat file. I have all the other stuff. The PDFs, I have it.
Okay, you should have this, the STAAD Pro workbooks and databases zip file. Open that, and here you will see 6 new folders. Select the one that says assign properties, and
Yes, I
here
did.
there is another zip file assigning properties to structural geometry. Open that zip file, and then you will see.
Yeah, okay. I missed that. Okay. Thank you.
Oh,
Yes, I got it now.
okay, perfect. So open the Imperial folder, and let's start with the first STAAD Pro model. Double click on the properties -1 file. Automatically, the application will open that specific file. This is the configuration, the license configuration that we're going to use: STAAD Pro basic license and structural select entitlements. If you need to change it, you can click on the configure licenses button and double check that. Oh, where is it? Oh, yeah. And double check that your license configuration looks like this: product type STAAD Pro, and additional licenses structural select entitlements. We click on the accept button. We ignore the message that says the additional charges. Again, you don't have to worry about that. And we click on the continue button. I'm gonna move this here. And okay, let me move this here. And this is the model we are going to use for this topic, assigning properties. The geometry is already here. We can see the nodes and lines. This is a uh, frame building. We only have the main structure here, braces, columns, and beams. So we're going to assume that we have created the required geometry so we can move to the next step. Remember the white bar? Here we're going to move from left to right. The next step is, or the next option is the properties option. We click on that option in the white bar, automatically the toolbar changes and it shows me the possible options, commands, or parameters that I can assign properties to the members. And on the right side of the screen, we also see a window that allows me to do the same. I can assign properties or modify something about the properties of the lines. Um, let's start by uh, defining cross sections. We have a line, yes, a line that represents beams and columns, but we need to assign a cross section to that line. And the line represents the center of gravity of the selected cross section. So in the STAAD Pro, there are two databases that we can use to create a steel cross sections. The standard database and the legacy database. Both options are indicated on the right side of the screen. We can see a button that says standard and another button that says legacy. But we can also access the databases using the icons in the toolbar. We have the first icon in the toolbar under the specification tab is a standard, and the second one is legacy. The standard database is the new way or is the new database included in the program. Basically, it has more graphic tools, an easy way to identify the shape and the dimensions of the cross section. For example, I'm going to click in the toolbar. For this example, I'm going to use the toolbar. Click on the standard icon. Here, I'm going to select the US database. Click on that option, the AISC 2023, and then select one of the possible shapes: angle, HP, M, pipe, whatever. Let's say W, W flange. Click on the W option, and automatically a new window appears. And in that window, I can see the shape and the dimensions of the W flanges sections. In the database, we cover the most typical sizes, the commercial sizes. They are ordered by size, and well, when you select one of these sizes, the figure on the right side of the screen will show you the dimensions of that cross section. So we could say that the new database, the standard database, allows you to see the cross section of an steel profile. And additionally, you can modify that cross section. For example, you can select a new property, modify the default property. The default property is just the cross section alone, the steel section alone. But we have an option to play the drop-down menu below the type specification label. We can modify it. For example, we can add cover plates at the top and at the bottom of the cross section. We just enter the width. For example, let's say, I don't know, let's say 1 foot, and the thickness of that cover, let's say, I don't know, let's say 0.1. And that way we can create, we can customize a cross section, adding cover plates, adding double profiles, adding I don't know, a top and cover plates. So this is up to you. Here you can play with the cross section that you want to assign to the lines. And again, this new database allows you to see the cross section. I'm going to click on the X axis to show you the legacy database. I'm going to close the dialog box, and this time I'm going to click on the legacy icon. I'm going to search the USA profiles again on the drop-down menu, and the advantage of the legacy database is that it allows us to select other type of materials. For example, timber sections. For example, the size of the timber section based on a code, and this is something that the new database cannot do. The new database only allows you to create a steel cross section. If you define a cross section for another material, we need to use the legacy database. For example, I can go again to legacy, select USA, and for example, let's say aluminum, and here the database will show the shapes on the left side of the dialog box, the white area, and the sizes presented as a list. The disadvantage is that we don't have a figure, we don't have an image of the cross section. So sometimes it's kind of difficult to know the size that we are using. I mean, there is a button that shows a full table with a full description of the cross sections. For example, I can click on the View Table button, a new window open, and again, we can see the same sizes that we see in the previous dialog box, but this table has more information like the depth, the width, the thickness of the flanges and webs, and more information. But again, it doesn't give you an image of the cross section. So it's it's kind of difficult to know the sizes of the real size of the cross section. Both databases work. So I mean, you can use the one you feel more easy to use. Basically, we will find the same cross sections in both databases for steel structures. For example, let me go again to standard, go to US AISC 2023, and select the shape W. And here we can see the sizes. We start, the smaller size is W4 by 13, and the biggest size is 44 by 335. So if we open the legacy database, we will see the same profiles. I'm gonna go to legacy, select USA, select the rolled steel cross sections, and from here, from the W shape options, the shape of the cross section, and well, here the order is different, but here we can see the same size that we saw on the other database, W44 by 335, and the smaller size is W4 by 13. And again, we have the options to add more or to modify the cross section. By default is a single section, but you can create a double profile or model a composite section. I mean, you mentioned that you are working on a project that requires to design composite beams. So if you want to define the cross section of that composite beam from the start, you can use this option. Specify the concrete thickness above the beam, the width of the concrete above the beam, and so on. So this is these are some tools that can help you to model any type of cross section and assign it to the lines. Regarding, we receive a lot of questions about this, and most basically all of our users ask us which database we should use. The answer is the one you prefer. In the end, we have the same properties on both databases, and we have the same areas, the same inertias for the cross sections. So it's up to you. You can use the new database or the legacy database. The disadvantage of the legacy database is that we don't have a figure, we don't have an image, and sometimes that makes things difficult. For example, the angles. It's always a problem to explain how this works. But well, this is how we call the angles in a STAAD Pro. It's we have five numbers after the L letter. The first two numbers represent one side of the angle in inches. The next two numbers represent the other side of the angle, the other leg in inches as well. And the last number is the thickness of the angle divided by 16. Or for example, this second section, 3 divided by 16. And that represents the thickness of the angles. In the workbook, you can see this a more detailed explanation. For example, again, we have the first two numbers represents the length of one of the legs. The other one is again the length of one of the other leg, and the last number is the thickness. This name for an angle represents an angle of 4 by 3.5 by 3/8. So I know it's kind of confusing, but once you get used to it, you can select different sizes from this legacy database without the need of an image, the dialog box. But if you want to do it easier, if you want graphic help, go to the standard database, select the US 2023, select the angle option, and here it's more clear the sizes of the cross section and how to edit the cross section because we have an image. But in general, or well, not in general, but the truth is that both databases will give you the same results. Both databases uses the same sizes and the same properties for all the cross sections. For this example, let's use the new database, the standard. And now let's create some sections. Well, let's select one cross section from the database and bring that to the model. So we're going to start by adding okay, let me change the shape on the left side of the standard database dialog box. We can find all the possible shapes. I'm going to go back to W to find a W flange cross section. And from the list, I'm going to select a W 14 by 30. Find the W 14 by 30. I'm going to use a single section. I don't want to add anything to the cross section. I can assign the material here. There is a drop-down menu with the available materials. The default is steel. So I'm going to go with the default, and then I'm going to click on the Add button. And automatically on the right side of the screen, on the Properties window, I can see the section that I selected from the database, W14 by 30. I'm going to repeat this process to bring all the cross sections for my steel members. I'm going to search for the W18 by 35. W18 by 35, single section made of steel. Click on the Add button, and I can see that cross section on the right side of the screen. Let's do it one more time, but this time I'm gonna change the shape. I'm gonna change it for an HSS rectangle. Remember, on the right side of the dialog box, you will see the available shapes for the US catalog. Um, from the list, I'm going to select the HSS 10 by 10, 10 by 10, and the thickness is going to be 0.375. I can see the shape of the cross section. For this type of cross section, I don't have the option to add anything. See how this drop down menu is grayed out. So the only way to use it is as a single cross section without any addition of plates or anything. So I'm going to use this. I'm going to use the same material as steel, and I'm going to click on the add button. Lastly, I'm going to add an angle on the left side of the screen, select the angle shape, and from the list, I'm going to select a 4 by 33, 3.5. This one, 4 by 3.5 by 3/8. This is gonna be my angle, and pay attention to the orientation of the angle. See the gray lines, the vertical gray line and the horizontal gray line in the image. Well, this point represents the line in our model. So what this is telling us is that the angle will be placed with this orientation, like not exactly parallel to any of the uh, global axis of the model. And we will see that later how to modify that. But the default is that the angle will be placed like this. I'm going to click on the add button, and the angle will appear on the right side of the screen. Those are all the steel cross sections that I'm going to use for this model. I'm going to close the standard database dialog box, and now I'm going to assign the cross sections, the lines in my model. The assignment process is going to be a 3-step process. Well, it's going to be a 4-step process. The first thing that we need to do is select the cross section from the list on the right side of the screen, the cross section that you want to assign. I'm going to start with this, the W14 by 30. So I select that cross section. The second step is highlight the members that will have that cross section. For example, I'm going to select the steel beams group. This model already contains a group. So let me, this thing is blocking me the tabs, but okay, at the top of your okay, in the toolbar, go to the select tab, and here go to the filter, was not here, go to the attributes icon, or find an icon called group in the toolbar. Once you click on that icon, you will see a list of groups that were defined in this model, and we're going to select the steel beams group, the first one in the list. So that's it. We have highlighted the members that will have the W14 by 30 section assigned. The third step is check the assignment method. On the right side of the screen, we can see the possible assignment methods. There are 4. We can assign a cross section the selected beams. We can use the cursor to assign the selected cross section, or we can use a list, or we can assign to view. Assign to view means that everything in your model will be assigned with the selected cross section. In most cases, and my preferred assignment method is the first one, the assign to selected beams, because it offers you more control of what you are doing. That's why I recommend this method. So verify that you have this method selected. And the fourth step is just click on the button Assign located on the bottom right of the window. We click on the Assign button. The program asks us if we want to proceed. Let's click on Yes. And now we can see a blue text next to the lines. The text represents the cross-section assigned to that line. R1, that represents the first cross-section this list. So we're going to repeat this process to assign a size all the lines in the model. We're going to with the next one. Remember, it's a 4-step process. First, we select the cross-section. Then we select the members. In this case, I'm going to do the selection using the groups. From the list, I'm going to select steel girders and steel, the steel girders, and unselect the steel beams. And only the girders should have a red color. Then verify the assignment method, assign to selected beams, and click on the Assign button. It asks us if we want to proceed. Let's say yes, and we will see a new label, a blue label assigned to the lines. This time it says R2. This is the section number in the list. We're going to do the same for the HSS. First, we select the HSS. Then we select the group steel columns and unselect the group steel girders. We check the method assigned to selected beams, and then we click on the Assign button. And yes, we say the program that we want to proceed. And that's it. We have assigned a cross-section to all the columns. We need to repeat this process one more time. We select the angle on the right side of the screen. Then we select the horizontal braces. Unselect the steel columns. Once we see the braces highlighted, we double check the assignment method assigned to selected beams, and then we click on the Assign button. So that's it. That's all. And now let's see other options to create cross sections. We have used a database to define the size of the cross section, but sometimes we need to create a user-defined cross section. For example, the concrete, if you're modeling something made of concrete, the column size is something that is not specific. There is not a list of sizes for concrete columns or a list of sizes for beams. So in those cases, we need to create the cross-section for the concrete elements. If you want to create a cross-section, we can go to, in the toolbar, there you can go back to the specification tab in the toolbar, and it will show you an icon called prismatic. And with this option, you can create the user-defined cross sections, or you can click on the prismatic button on the right side of the screen. Both options will lead you to the same dialog box. For example, let me click here, prismatic in the toolbar, and the dialog box, the options to create my cross sections. Let's say that I want to create a square concrete column. From the available shapes on the left side of the dialog box, I'm going to select rectangle. I can see an image that explains the parameters. The YD is the depth. And here I'm going to type, okay, and this is something interesting. We have the input units. The input units are, by default, are feet. So if you prefer to enter the units using another, if you prefer to enter the dimensions using other units, this is the time where you can change the input units. For example, I can close this dialog box. I can go back to the geometry tab in the toolbar, click on the icon that has a pencil and a rule, and here I can change the length unit, and then click on the apply button. And I can access again the prismatic dialog box, but this time I can use the button on the right side of the screen, the prismatic button. We'll see the same dialog box that we saw before. Here we can change the shape to rectangle again and see that now the input units are set as inches. So probably it's easy to enter dimensions using inches, but well, that depends on you. So let's say that I want to create a square column, 16 by 16, and I can select the material from the start. And I'm going to select the concrete as the material. Click on the Add button, and the cross section will appear on the right side of the screen. It's similar to the steel cross sections. So now let's say that I want to create the cross section for the concrete beams. And here I'm going to specify 16 for the YD and 24. Interesting. I think this is not okay. Okay, let's follow the workbook. 16 Y and 24 inches the Z direction. I'm gonna click on the Add button, and I have created a second cross section. So now I'm going to assign. Sorry, I'm going to create another cross section, a round cross section. Using this same dialog box, I'm gonna go to the circle shape, and here I'm going to define a 1 inch circular shape. But this time I'm going to change the material. I'm going to change the material to a steel to define a cross section of a steel rod. Once I have defined this, I can click on the Add button, and that cross section will appear on the right side of the screen. Now that I have created the new cross sections, I need to assign them. So I can close this dialog box, and I can repeat the process that we used before. I'm going to open the groups window. I'm gonna go to the select tab in the toolbar, select the attributes option, and search for the group icon. Once you find the group icon, you can use the groups to select specific lines in your model. So I'm going to start with the column, the 16 by 16 column, and then I'm going to select the group concrete columns, see how they change to red. Double check the assignment method, assign to selected beams, and then click on the assign button and click on yes. And see how the label appear next to the columns. R5, which means is the section number 5 in the list. We repeat this process for the beams. I select the let me see. Okay, select the section number 6, 16 by 24. I'm going to select the concrete beams group using the select groups dialog box. Unselect the concrete columns, double check the assignment method, and then click on the assign button. And lastly, we're going to assign a cross section to the vertical braces. In this model, the vertical braces are a steel row. So let's select the circular section from the list on the right side of the screen. We're going to select the B braces group in the dialog box, only that group. Double check the assignment method, and then we click on the assign button to proceed. And that's it. Now all of our lines have a cross section assigned. As an additional comment, if you have a complex geometry, if you have too many lines, probably by mistake you didn't assign a cross section to one line or maybe two lines. So if you want to double check that everything has a section assigned, we can go to, again, to the select tab in the toolbar. We can go to the attributes option and search for the missing property icon. Here you can search for, I don't know, maybe a missing elasticity, modulus of elasticity, or missing property, whatever you want to use to search for something that is missing. But the most common is the missing property. So let's click on the missing property option. And if everything is okay, we shouldn't see any line without property. If there is a line without properties, the program will show you the element, will highlight the element without the property. A common question is, how can I reassign the size of an existing element? The truth is, it's very easy. Just assign a new size and it will overwrite the previous size. For example, these beams. They currently have this cross section, W14 by 30. Let's say that you want to assign a new cross section. So let's say that I want to assign this section, W18 by 35. So I just need to select the section that I want to assign, select the element that will have a new cross section, verify the assignment method assigned to selected beams, and then we click on the assign button and click on yes. And that's it. That's how you can reassign cross sections. Now that a specific element has a new size assigned to it. So let me go back to the default. Let me change the size one more time. W14 by 30. Select that line, verify the assignment method, and click on the assign button on the bottom right of the window. Another thing that it's very common in this when we assign properties is the orientation of our cross sections. For example, for the columns, probably the major moment of inertia is not correct. Maybe we want to rotate the columns, cross sections, 90 degrees, or I don't know. There are cases where we need to modify the default orientation of the members. So the first thing that we need to do is check a render view. Check the current orientation of the members. To do that, we can go to the View tab in the toolbar, and then select well, the Windows icon in case you see it, and then search for the 3D rendering icon. Click there, a new window will appear, and this window will show you a render view of your structure, and it shows you the orientation of the elements. And here I want you to notice that the angles are, well, the default is like is not well centered. We could say that. I mean, the legs are not completely horizontal, and they are not completely vertical to the structure. So this is a common thing that we modify on this type of elements, the orientation of the angles. The columns, for this exercise, the columns have a square shape, so it doesn't matter the orientation of the column. But keep in mind that if you're modeling W flanges as columns, you must check the orientation, because probably the column is not oriented as you want it. But well, this is a 3D view that helps you to double check the default orientation of the members. But this is a separate view. This is like a new window to see the structure. We can close that window, and if you want to see a render view that always appears in the visualization window, so you don't have to turn on and turn to click again on the 3D rendering icon. If you want to always see a 3D render on the visualization window, you can go to the View tab, click on the first icon in the View tab, and in the dialog box, okay, in the dialog box that appears, here you can go to the structure tab, and in the 3D sections area, we can change it to full sections. And this will allow us to see a render view of the elements all the time, always in the visualization window. Probably when we assign properties is useful, but when we start applying loads, it gets difficult to see the loads. So it with caution. Only turn on this when you think it's useful. So let's change these to full sections, and I'm going to click on the OK button, and now we can see a render view of the cross sections assigned to the elements all the time in the visualization window. So we can see how we can modify the orientation. And again, here we can see that the angles are not, the legs of the angles are not completely horizontal, and they are not completely vertical. So in this next step, we are going to modify that. The program allows you options. For example, we can assign a beta angle called angle, and that will tell the program to force the orientation of the angle this way. This short leg of the angle will be completely horizontal. If we select another configuration called R angle, the long length of the angle will be horizontal. And this is the default. This is how we are seeing the angles right now, like this kind of inclination for the two legs. So let's do that. Let's see how that works. So first, I'm going to create the beta angle specification in the toolbar. We can use the toolbar, or we can use the window on the right side. Again, both options will give you the same, will show us the same dialog box, but I think it's easy using the toolbar. So we go to the specification tab in the toolbar, select the beam icon. We will see different options, and here we're going to the beta angle, the option at the top. When you click here, we are going to select the angle option. Remember, this is to tell the program that we want that the short leg is horizontal to the local axis of the cross section. We will see that in a minute. We're going to select angle, then we're going to, we need to assign it right now. So let's, sorry, I should have selected the angles before opening this dialog box. So let me cancel this. Let me close the dialog box, and I'm going to select the angles one more time. Do it faster. I'm going to go to the select tab in the toolbar. I'm going to go to the attribute option, select the group icon, and from here I'm going to select the H braces. These are all the angles in my model. So I'm going to go back to a specification toolbar, select the beam icon followed by the beta angle, and here I'm going to change the angle to angle. The assign will be to the current selection, and then we are going to click on the OK button. And now you will see that, well, maybe it's not too clear, but now the short leg of the angle is completely horizontal. Let me see if I can, let's filter the view. Select only this angle. I'm gonna go to view and use the selected objects icon. And here we can see, can rotate the view with my arrows and see how the short leg of the angle is horizontal, or is parallel to the X and Z axis. But well, that's the idea of this, that we can rotate the angle to change the direction of the legs. We can repeat the process again to show you the other option. Let me display the whole structure again. In the toolbar, we can click on the display whole structure. we can go to the specification tab in the toolbar, select the beam option, select the beta angle. This time we're going to use the other option, R angle. Remember, this will change. Now the long length will be horizontal. R angle. Oh, I forgot to select the braces one more time. H braces. Select all the angles in the model. Modify the beta angle to R angle and apply it only to the selection and click on the OK button. And if I take a closer view, I will see that the long length of the angle now is parallel to the horizontal directions. Okay, let me go back to view, select objects, and if I rotate this, okay. If I rotate this, I can see now that the long leg is horizontal, completely horizontal. So those are usable options for angles. So you have to enter or calculate a rotation angle. For the other types of shapes, it's more easy. Let me display the whole structure again. For example, for a column, if you want to rotate that column 90 degrees, you can go to the specification tab, select the beam icon, select the beta angle, and specify the angle of rotation. So that's how you can modify the orientation of the cross sections. Another thing that that will help you to modify the rotation is the local axis of the elements. Right now, we have talked about global axis. Y is the vertical global axis, X and Z are the horizontal global axis. But when we draw lines, every line has a local axis. How can we see the local axis? Well, we can go to the View tab, select the first icon in the toolbar, the label settings. Remember, this icon will always help us to see different information in the visualization window. And one of that information is the local axis of the members. We can select the labels tab and then select the beam orientation. Select the beam orientation from the list. See that it has a no letter. You can use the keyboard, press the shift key and the O letter, and that will turn on the beam orientation axis. We can click on the apply button and we will see that now every line has 3 arrows. Maybe this is the moment where we should turn off the render view to easily interpret the local axis. I'm going to go again to label settings under the view tab, go to the tab and change the 3D sections. No, I just want to see the lines. Click on the OK button and now we can see the local axis. And something that can help us is that the cross section is indicated with the local axis. You can see here the W flange section in red. And for the columns, we can see the square column in red as well. So these are the local axes. We have 3 for each line. The blue color is the longitudinal axis. Okay, the local X axis is the blue. This is the longitudinal axis. The local axis Y is the red arrow. So you can see here that the red arrow always points to the major moment of inertia. And the green arrow is the local Z axis. And it always points in the a minor moment of inertia. So when we apply rotations, the rotations always go from the green arrow